Welcome to part 3 of the Snowtracks shaded tutorial by Beerplay. A few days ago I turned 31 years old, which has nothing to do with this tutorial, but I just wanted to let you know. So I'm sure you're eager to know how to create this Snowtracks shader, and in this part I'll teach you how to draw to the splat map during the game. The principles we'll cover in this part will be applied to the wheels of some car model in the next part. So in this part we will create two different scripts. The first thing we'll create is a draw shader that we require to specify how tracks are drawn, and the other thing we'll create is a C# script, which we'll call draw with mouse. The result of this part will let you draw Snowtracks by holding down the mouse button. In the previous part we left off with our tessellation Snowtracks shader containing a splat map. Instead of using this pre-made texture, we will now create a render texture and draw to that image. So this slot will be filled with that image. We can do this through a C# script and an Unlit draw shader. So let's make those scripts. Let's start by adding the Unlit shader. So go to Create, Shader, and select the Unlit shader. And we'll call this Draw Tracks. Now we also need a C# script. So let's right click, Create C# script, and we'll call this Draw with Mouse. Now I've opened up both files in Visual Studio and we'll start with the Unlit Draw Track shader and switch back and forth between the C# and the shader file. Now the first thing we'll do in the shader is remove all the statements about fog, because we don't need that. So first go to line 17 here and remove the fog here. And we can also remove the fog here. And this line is about the fog as well. And we can remove these lines as well. Now the entire function of this shader is to add red pixels at a certain position to another texture. So this shader requires two extra properties, the coordinates and the color to apply. So let's add those properties. So underneath main text we're going to type coordinate. And we'll call this coordinate as well. And it's going to be a vector. And in C# we've got a vector 2, 3 or 4, but in shaders we only got a vector which consists out of 4 elements. And we need to specify a default value, and that will be 0, 0, 0, 0. Now in the next line we'll add a color, and we'll call this draw color, and it's going to be a color with the default values of 1000, which is red. Now the vector and the color are a fixed 4, so in the subshader we can add the fixed 4 of the two values. So let's type in here fixed 4, and we'll get the coordinate, comma, and we'll also get the color. Now let's save this shader for now and go to the draw with mouse C# script, and we'll return to this shader at a later state. Now similar to how we draw height on terrains in Unity, we want to raycast the position of the mouse, and when the user holds down the mouse button we will send the coordinates to the shader and draw Snowtracks at that point. To do this we need two public variables, pointing out to our draw shader and to the main camera. So let's start at the top and write down public camera, and we'll call that camera. And we also need a public shader, and we'll call that the draw shader. The next thing we need is to instantiate a new render texture, which will be the splat map. Until now we've just used a pre-made image, but we want to start with an empty black render texture. So let's type private render texture, and we'll call this Splatmap. The last thing we need is to add two materials. One material refers to the Snowtracks shader, and the other material will be based on the draw shader. So let's write private material, and we'll call this snow material and draw material. Now in the start function we're going to assign the draw shader to the draw material. So let's say draw material is a new material and it's going to use the draw shader. Now we can access all the properties from the draw tracks, so we're going to set this property color in the C# script. So draw material dot set vector, and we're going to set the vector color to color.red. Now we'll place this script onto the plane that carries the snow shader that we've created in the previous part. So we can say here that the snow material is get component, the mesh renderer, and we want to get the material, and that should be the tesselation shader. Now we want to create a new render texture called Splatmap, and we'll apply that to the snow material. So let's say Splatmap is a new render texture, and here we have to specify the size of the render texture, and I'll say 1024 for now by 1024. The depth is going to be 0, and the format is going to be render texture format dot argb float. And now we'll speak to the snow material dot set texture, and we're going to set the splat to use the splat map. Now let's save this script and go back to Unity. Now in Unity select the plane, and we'll drag and drop the draw with mouse onto the object. Now select for the camera the main camera, and the draw shader is going to be draw tracks. Now what this script will do is it will replace this splat map with the render texture that we've just created, and it will remove all of the snow tracks once we play the scene. So let's try it out. All of the tracks are removed, and if I go to the shader and to the material, we'll see a render texture here, which is all black. Now we are going to create a script that allows us to draw with the mouse on the mesh to the render texture. And to do this we're going to raycast the mouse position. So we'll create a private raycast hit, and we'll call this hit. Now let's add an if statement if we are pressing down the mouse key. So if input dot get key code dot mouse 0, so the left mouse button, and we'll create another if statement for the raycast. So if physics dot raycast, and we'll get the camera dot screen point to ray, and what we're going to get is the input dot mouse position, and out is going to be the hit that we created. So if we're pressing down the mouse button and if we're raycasting towards the mesh, then we can get some information from the raycast hit, because hit has got this information of texture coordinate, and this is the texture coordinate of the UVs of the mesh, and we can send that to the shader. So what we are going to do is we're going to talk to the draw material, and we're going to set the vector of this draw material. And which vector are we going to set? In the draw tracks we see here the coordinate, so we're going to set the vector coordinate to a new vector 4. And what we need is the hit dot texture coordinate dot x, and we need the hit dot texture coordinate dot y. And as it's a vector 4 and we don't need the z and w value, we can set this to 0 and 0. In a moment we will specify in the shader what our brush will look like, but in this script we need to apply the brush to the current render texture. And to do this we need to first write our render texture to a temporary texture, and then apply the draw shader using graphics.blit. So we're first going to create a temporary texture. So we'll say render texture, and we'll call this temp. Is going to be a render texture dot get temporary, and we first need to specify the width and height. So we'll say the Splatmap dot width and the Splatmap dot height. Now the depth buffer will be 0, and we'll use the render texture format dot argb float. Now that we have our temporary texture, we can use the graphics.blit. So graphics.blit, and we'll write the Splatmap to the temporary texture. And now we'll use the graphics.blit again, and we need to specify first the source. The source will be the temp, the destination will be the Splatmap, and we'll use as a material the draw material. Now there's one more important thing. We've created a temporary texture, but we're not removing it from memory. So we have to say here render texture dot release temporary, and we'll fill in here temp. Otherwise Unity will keep creating a temporary render texture and won't remove it from the memory, and with release temporarily it will be removed each frame. Now for the sake of this tutorial, let's also show the Splatmap on the onGUI function. So we'll say a private void on GUI, and we'll say GUI dot draw texture, and what we're going to draw is a new rect, and the rect will be at 0, 0 in the left corner, and it will be at 256 times 256. And what we're going to draw is the Splatmap, and we'll use scale mode scale to fit, because the Splatmap is at 1024 at this moment. We'll say that the alpha blend is false, and we'll set it to 1 as the image aspect. So now if we save the script and go back to Unity, and apparently I made a typo. This mouse should be a capital. So let's save this again and go back to Unity. Now we don't have any errors anymore, and if I start the scene, you won't see anything happening yet, but we'll see the render texture up in the corner. So let's create our shader. We'll go to draw track shader, and we'll scroll down to the frag. Now we want to spawn a brush where we have clicked on our mesh. And once we click the mesh, this shader is being drawn onto the render texture. As you can see, we are using the draw material only when we click on a certain position on the mesh. The UV coordinates are always between 0 and 1, and anything we type here is being calculated on each pixel of the render texture. So if we would do a distance check between the current pixel and the coordinates, we know which pixel is at the same place as the coordinates when the result of that check is 0. But we want to draw a color, so we need to invert the outcome of our distance check. So we can do this by typing a 1 minus. So let's start by typing a float, and we'll call this draw, and we'll start with 1 minus, and here we're going to do a distance check. So we'll type distance, and we want the distance between the i.uv, that's the current pixel we are checking in the shader, and the shader will run on all the pixels, and we're going to compare this with the coordinate that we've got, and we want the x and the y of that. Now we want to make sure that our value is always between 0 and 1, so first we're going to saturate it, which is the same as the clamp 01 in C#. So saturate everything between here and here. And now if the value is above 1, it will be a 1, and if it's below 0, it will be 0. Now we also want to set a brush size, so we can do this by using pow and put this around everything here, and we can put this to the power of some number, and the lower the number is going to be, the bigger the brush is going to be. So if we use a high number, the brush is going to be very small. Let's just keep it at 50 for now, and we'll look at this later and make it a public variable. Now the next thing we'll specify is the draw color and the draw strength. So we'll specify a fixed for here, and we'll call this draw call. And it's going to be the color that we've got as a property multiplied by, between parentheses, the draw that we've specified before this, and we're going to multiply this by some strength, and for now we'll just use 1, and we can change this later as well. Now what we want to return is the saturation of everything together, so we want to get the color plus the draw call. Now we need to remove this return, and that should be all for the shader. So let's save this script and go back to Unity. And in Unity it's time to test out our scene. We should see some live changes to the terrain as well as the GUI texture when we click on a terrain. Now the brush is quite big, so let's change the size in the shader while still in play mode. Shaders can update live opposed to C#. So let's change to a smaller brush size, so I'll set it to 200. And let's also set the transparency to 0.1. Save this and go back to Unity. And while still in play mode we can draw again, and we'll now see a very small brush with also less opacity. And we can create some very cool stuff here. That's it for this part. In the next part we will apply this to individual wheels of a car driving through the snow. At a later stage we'll also make snow reappear, and we might even look at some custom brushes to create footsteps in the snow. But for now I want to thank you for following this tutorial. If you like this tutorial, give this a thumbs up, and if you want to stay updated with new tutorial parts, subscribe to the channel. To support me in creating these tutorials for free, consider becoming a patron on my Patreon. See you next time.